So now that we've taken a look at how the example works, where we're going to be creating a bunch of set objects that contain the unique words of Shakespeare and collect them either concurrently or non-concurrently and so on, let's take a look at how the concurrent set collector is designed. And this is a really interesting collector. And we'll talk about this in more detail. Most of the predefined collectors you get out of the box from the Java collectors utility class are non-concurrent collectors. And that includes things like toList and toSet and toMap. There is a concurrent collector that's a map collector, but we want to have a concurrent set collector. And so we're going to design our own collector that's going to work on concurrent. It's going to work for concurrent collector semantics, not sequential collector semantics. And in particular, it's going to accumulate all the elements in the stream that we're using the collector for into something called a ConcurrentHashMap.KeySetValue, which is a projection over top of concurrent hash map that takes the hash map generic interface, which takes a key value pair, and turns it into a set interface that just takes a generic key. And you'll see how that works. And this whole thing, of course, is just an encapsulation over set. So here's concurrent set collector. You can see it takes an element E, which is the stream, and an element S, which extends set. And then it implements the collector interface. This is one that comes out of Java, part of the Java util stream package. And we have E, set of E, and then S, which is this thing that extends set. So E is the element, S is the type of the it's the type of mutable result container, and then S is the type we're going to return as the result of this thing. So we've got a field here called set supplier. This is going to be used to create the appropriate set. And we also then have concurrent set collector. And you can see here that this is just the constructor that takes the supplier as a parameter. Then we have the supplier factor method. And you can see what we do here is the supplier factor method for the concurrent set collector returns a new KeySetValue instance. And this syntax, again, is good old Java constructor reference syntax. So ConcurrentHashMap : new KeySet, which is a method that makes a new KeySetValue object. So it's a factor method that returns a new KeySet object. And we're doing this, we're using the KeySetValue as the type of the mutable result container so that different threads that are running can all collect into the same collector concurrently without having to worry about corruption with multiple threads messing up the internal state of the mutable result container. So this is intentionally designed to be thread safe. Here's the accumulator method. The accumulator method simply uses the add method to add the element to the map, which of course in this case is going to use the ConcurrentHashMap.KeySetValue add method. So that'll work properly. And then down here, we're going to go ahead and have a combiner, which for this particular case is not going to be used because it's a concurrent map. It's used using concurrent collector semantics, and it's intended to be used with a parallel stream, so there's no need to have a combiner, but we have to put one for syntactic purposes. So for all intents and purposes, let's say this method isn't really necessary when a parallel stream is used. However, we also use it with a sequential stream, so we need to provide an implementation here. So if we were only using this for parallel streams, this wouldn't be necessary, but it's always necessary for syntactic reasons. Here's the finisher. So the finisher is one of the more interesting factory methods defined on the collector interface. And what it does is it can be used to convert whatever the mutable result container is into the final type that we want to give back to the user. And here's how it works. This is really cool. So we use our set supplier factory method to get the type of set that we are making. And then we check to see whether or not the type of set we're making is an instance of ConcurrentHashMap.KeySetValue. In particular, if it if it indeed is the concurrent hash set key set view, which is what we are going to pass down here. Let's see if we can find that one. There we go. This guy. When this is actually passed in as being the key set view, then in that case, this will turn out to be true. This so-called downcast or instance of check. We're saying, is this thing a key set view, or are we trying to get the result back as a key set view? And if so, we've already got our mutable result container in key set view format. So we don't have to do any conversions. We just return the result. So if we're using the concurrent key set view implementation, we take what we have at this point and just pass it back unchanged. However, if we're trying to change into a different format, for example, in the case where we pass in a tree set, we want the results to come back as a tree set, not a hash set, then we have to go ahead and add all the elements from the key set version into the tree set version, or whatever this other set is, and then return that. And so that's why, when we take a look at the results here, the tree set implementation is a little bit slower than the hash set, because the hash set doesn't have to do any other conversions, whereas the tree set has to put the contents of the key set view, which is the concurrent hash set, into a tree set before it returns it. And again, it's still faster, but we had to do that extra conversion. The last method here that's interesting is characteristics. And you can see here that it simply says we want the results to be concurrent and unordered. When it says it's concurrent, that means it's a concurrent collector, and that tells the streams framework have all those different threads collecting into it simultaneously. And then we have one other method, which is the toSet factor method that makes a new concurrent set collector given the map supplier that's passed to it. So very, very powerful example of how you can use custom collectors in order to encapsulate the features of Java and modern Java streams in order to be able to define a generic framework for concurrent collectors, in this case, concurrent collectors for sets. We will take a look at concurrent collector for maps in a subsequent lesson.